As part of a credit recovery project for Physics 240, I have been assigned problem 15 from Midterm 2. In this problem, we're trying to find the voltage drop, or the voltage across capacitor C, after the switch has been closed for a very long time. They tell you other information, but the key things are that R1 is equal to 12 ohms, R2 is equal to 6 ohms, and that the EMF of the battery, or the voltage of the battery, is 12 volts. So two ideas you'll need to understand is that Kirchhoff's loop law states that the sum of the voltage drop around any loop must be 0. So because the loop has been closed, or the switch has been closed for a very long time, we're mainly only caring about this inner loop here that goes from the battery through R1 through R2 and back to the battery. So Kirchhoff's law can be written as the EMF of the battery minus the voltage drop across the first capacitor, which can be written as the resistance R1 times the current through R1 minus R2 times I is equal to, all that is equal to 0. But we also know that the voltage drop across any circuit in parallel has to be equal. That means that the voltage drop of R2, or the voltage drop of R2, has to equal to the voltage drop through C, or the voltage between this point, or the potential difference between this point and this point, is the same. Therefore, we really want to solve for the voltage drop through R2. So first we need to find I. So we're given EMF is equal to 12 minus R1, which is 12, I, minus R2, which we're given is 6, I, all has to equal 0. Once you move these two pieces to this side and then divide, you get 12 divided by 18 is equal to I, or I is equal to 2/3. Using this, we can now calculate the voltage drop of R2. Times So we calculate that the voltage drop of R2 is 4 volts. And because we know that the voltage drop across a circuit in parallel has to be equal, we know that the voltage across the capacitor has to also be 4 volts. And that is answer A. And that's how you do that problem.